Yo, what's up everyone? Welcome to Descriptive / Laboratory Chemistry Part 6. Today we're going to be talking about flame test colors. Okay, so what is a flame test color? When you put a compound containing a certain metal ion over a flame, sometimes a characteristic color is given off. And flame test colors are a way to classify what a compound is, or like what metal is in a compound. So for example, if I have some unknown compound and I put it under a flame, and I see that it gives off this characteristic reddish color, then I know that within that compound, you're going to have lithium in it. Now, flame test colors are going to depend only on the metal ion. So you can see in this chart here, you have a bunch of compounds containing chloride, but all their flame test colors are different. The reason for that is because the chloride has no effect on the color of the flame. The only thing that's going to affect it is the metal ion. So lithium produces this reddish color, copper produces this greenish color, calcium yellow or like orangish, sodium is yellow. And so flame test colors can be a helpful way to classify what metal ion is in an unknown compound. Here is another helpful diagram that has the colors in like word form, I guess, not in like a picture. So you have a bunch more here. So let's see how these types of problems can come up on the USNCO test. So you have a solution of a salt of which metal produces a bright red color in a flame test. So let's go through all the answer choices to see which one makes the most sense. So first of all, we have lithium. Lithium is right here. Lithium produces this magenta to carmine color. That's kind of reddish, so we can kind of keep that. Sodium is right here. Sodium is an intense yellow, and that's clearly not red, so we can't have sodium. The next one that we have is potassium. Now potassium is right here. Potassium is lilac to red, and that's more pinkish than really bright red, so we can't really have potassium. And then copper kind of depends on what charge it has, but usually it's going to be blue or green, which is not red, so we can't have copper. Therefore, the only logical answer is lithium, which is the answer. Let's look at one more. So which ion gives off a green flame test? Let's go through all the answer choices again. So number one, potassium. Potassium was the lilac to red, so that's not green. Calcium. Calcium is up here. Calcium is orange to red. That's not green. Strontium. Where's strontium? Strontium is here. Strontium is crimson, which is also not green. So last one, barium. Barium is over here, which is pale / yellowish green, which is, I guess, green. So the only answer that makes sense is D. Now, you might be wondering, why do flame test colors happen? So let's say we have a metal ion here. And of course, the metal ion has a nucleus in the center, and it's going to have electrons orbiting around it. Now, in this diagram here, the diagram that we use to kind of explain flame test colors includes electrons going around in these shells. So although this model is kind of wrong, it's really helpful to show why flame test colors happen. The electron can stay in the shells, but it cannot be between the shells. So I can have an electron at level 1 or level 2 or level 3, but I can't have an electron in the center of 1 and 2. So that cannot occur. And this model here only has one electron just to show what's happening on a single electron level. But of course, a actual metal ion would have more than one electron. So let's say this electron starts off at the level 1 shell. It starts off in its ground state. What happens is that when we add flame to it, the electron gets excited. It gains energy. And when it gains energy, it has nothing to do but to move up in energy level. So in our electron here, let's say it moves up from level 1 to level 3. So currently, this electron is in its excited state. Its ground state is level 1, but currently it's at its level 3 state, so it's excited. Eventually, this electron needs to come down. And so let's say the electron comes down from level 3 to level 2. When that happens, where does the extra energy go? The energy that it gained from the flame needs to go somewhere. And when it goes down in energy level, what happens is that electron emits that energy in the form of electromagnetic radiation. So it lets that energy go. And if you look at the electromagnetic radiation spectrum, there's a certain tiny bit where you have visible light. So certain wavelengths that are emitted are visible light. So depending on where the electron starts off and where it ends, you can have visible light being emitted. In this case, we went from the third energy state to the second energy state, and that is part of the Balmer series. If you look, going from the third energy state to the second energy state produces or gives off red light. If you went from the fourth state to the second state, that'd be green light, and then 5 to 2, blue, and then 6 to 2, that's purple. So the Balmer series is the, electron jumps that produce visible light. Now, let's say you went from the third state to the first state, all the way down. Now, you would still be emitting electromagnetic radiation. It's just that the wavelength of that light is not visible light. You would have UV light. And if you went from, say, the fifth down to the third, you'd be in the Paskin series, which would produce infrared light. So really, the reason that those certain metals produce visible light is because they are in the Balmer series. When the electrons get excited and they come down, they produce this visible light that we can see. And that's it. So an electron gets excited, and when it comes down, it emits light in the form of electromagnetic radiation. And if it's in that correct frequency or wavelength, then you can sometimes have visible light. And that's how we use flame test colors. I hope you were able to learn something, and I hope to see you later. Thank you.